Hey everyone, in this video we're going to go through the 2024 Heff trial exam, number 2, and doing question 9 and 12 from the multiple choice and questions 2, 3, 4 and 5 from extended response. So it's probably going to be quite a long video, so feel free to pass forward wherever you like. Alright, so questions like question 9 do often appear in the VCAR exam, so it's very important that you understand what is actually going on here. So we've got what we've got we've got a definite integral is equal to 1, and then a negative 2, and then we've got f of x minus 2x dx is equal to. So always take note of what is happening in your terminal. So we're going from 2 to 3, and then 2 to 5 and 3 to 5. And we want 2 to 3. So let's have a look at this in terms of a number line. Might be a little bit easier. So we're going from 2 to 5, and let's just put 3 and 4 in the middle. 3 and 4. So f of x dx is equal to 1 from 2 to 5. So going from 2 to 5, that is equal to 1. And then from 3 to 5, that is equal to negative 2. And then from 2 to 3, so if we want this, basically that's going to be 1 minus negative 2, which gives us 3. Now, we've got to take note, that's for, let me just do it, oh, I'm running out of space. Let me do it up here. So we're going from 2 to 3, and that is for f of x dx. All right, so that is equal to 3. But we want f of x minus 2x. So we can just separate. So we're going 2 to 3, f of x dx minus 2 to 3, 2x dx. All right, so basically we just have to work out what this is, and then we can add it to 3. So probably shouldn't have done such large number lines, but anyway, our antiderivative of 2x is x squared, so nice easy one. Oh, we could do this on our calculator. Why am I doing it on here? Anyway, so 3 squared is 9. And then 2 squared is 4, so 9 minus 4 gives us 5. So we got the 3 from using our number lines, and then the 5. So 3, we're going to have 3 minus 5 gives us negative 2. So our correct answer is C. These types of questions can be a little bit confusing. You can have negatives. Remember, definite integrals can be negative, but I would encourage you just to put a similar question or similar questions in your bound book, and then, because some of them are pretty straightforward, this one isn't as straightforward, but I think still achievable. So probably a good idea to put it in your bound book. All right, let's scroll on to question 12. So let A and B be two independent events from a sample space where A is equal to probability of A is equal to 3 times the probability of B, and the probability of A or B is equal to 0.37. Probability of A given B is equal to. So the important thing here to note is they're independent events. So whenever you see independent events, you need to think of your independent events formulas. So you should have them in your bound book. Let me just write them over here. So the probability of A and B is equal to the probability of A times the probability of B. All right, this is only true if they're independent events. And then the probability of A given B is equal to the probability of A. So if they're independent, then these will be true. Okay, so the left-hand side equals the right-hand side. So you could use these, and I always love, whenever I see two events like this, I love a two-way table. So I'm going to just start by doing a two-way table. So we're going to have A, not A, and B, not B. Just quickly sketch it out. All right, and remember they all have to add up to 1. So we don't know what A is, but we know it's 3 times what B is. So let's call B X, and that means A is 3 times X. Probability of A or B is 0.37. So at this point, I'm like, well, I probably need a few more formulas. So we can use the addition rule, which should also be in your bound book, but it's also on your formula sheet, I'm pretty sure. So A or B, it's also not a difficult one to remember. She says, you know, because she's just been using it for a very long time. A and B. All right, so we know A or B is 0.37, and I've got probability of A is 3x, probability of B is x minus probability of A and B. So we've got 4x. Sorry, I've got a runny nose. So this is going to give me 4x. So the probability of A and B is equal to, so just moving things around, 4x minus 0.37. Probably don't even need that two-way table. Now I can start saying, well, can start using this. All right, so we've got 4x minus 0.37. All right, that's the left-hand side of that independent events formula, is equal to the probability of A, which is 3x, times the probability of B, which is x. Now, I could tidy this up a little bit if I wanted to. So remember, that's 3x squared, 4x minus 0.37, and I could just do solve on my calculator. So let me just get the calculator. Sorry for the sniffles, guys. It's terrible. I'm sure it's very loud and not pleasant. So 4x minus, can we get a 0 down there? 0 point, can we get a point? Oops, that's not a point. Let me just move my calculator up because that's from the wrong spot. 0.37 equals 3x squared. So 3x squared and comma x. Beautiful. All right, I don't have it in exact mode, so let's just put that puppy in exact mode. So x is equal to either 1 on 10 or 37 over 30. Now, just take note that probabilities have to be between 0 and, what am I doing? 0 and 1. So clearly that second solution is not possible. So x is equal to 1/10, which is the same as 0.1 because our answers are in decimals. And we want probability of A given B. So we can use this formula here. So the probability of A is 3 times 0.1, so our answer is also C, 0.3. All right, for the remainder of the video, I'm going to have to use the original Word document because it was just pointless screenshotting so many questions into that previous Word doc. Now, I am going to be going through questions 2, 3, 4, and 5, but just for time and also my nose is running, so it's very frustrating making these videos. I might just tell you about questions that are probably ones that you need to leave on your exam, okay? Remember, your time is precious. You should be spending your time doing questions that you know you're going to answer well. All right, so let's have a look at question number 2. The parabolic cross-section of a rail tunnel is modeled by the function. Okay, so we've got that. And remember, we can use our calculator, so I didn't really use my calculator much in those previous two. Where x is the horizontal distance in meters from an origin, and y is the vertical distance. Maybe we'll make this a bit smaller so we can see it a bit easier. In meters over the horizontal base of the tunnel, the graph of F is shown below. Write down in terms of A the domain of F. All right, so we've got our domain is going from here to here, which are our x-intercepts. So this one here is clearly negative A. So remember, we're just going to let these factors equal 0. That this dilation factor does not affect your x-intercepts. And then this one is x minus 5a. So that's going to be 5a. All right, so we've got negative A to 5A, and I think where they're included, where f of x is greater than or equal to 0. Beautiful, so they're included. All right, moving along. All right, so that you should be able to get that question. 1 mark. State the equation of the axis of symmetry of the graph of f in terms of A. So remember, your axis of symmetry is where it separates the graph in half. All right, you would have done axis of symmetry when you started doing parabolas, but you don't really see it much. It is halfway between your two x-intercepts, so you just add them together and divide by 2. All right, again, you can do that on your calculator, but that is going to be what, 4a over 2, so that's going to be 2a. So that's at x equals 2a, and then to get the corresponding, oh no, we just want the equation, sorry. So x equals 2a. All right, another easy mark. Find the, and that should be in your bound book anyway. So if you're thinking, oh, axis of symmetry, I don't remember that. You would have done it in Year 10. All right, it's like in the Year 10 textbook, it's one of the very first things that you do when you look at parabolas. Sorry, I need to drink some water as well. Stay hydrated. All right, find the values of x in terms of A for which f is strictly increasing. All right, so I'm going to get my thing out. So it's strictly increasing from negative A to our turning point there. All right, so from negative A to 2A, let's just scroll down. Let me scroll down. All right, so negative A to 2A, and those values are included as well, so we need square brackets. Find the values of A for which the maximum height of the tunnel is less than twice the width of the base of the tunnel. So the maximum height of the tunnel is less than twice the width of the tunnel. Oh gosh, sorry. All right, so we just need the height of this tunnel. Now remember, we can use our calculator. Let me just scroll up. All right, need to write that down. Okay, so we just need that maximum. So on my calculator, all right, I'm just going to put that in. I feel like I should define it. I might actually define it. So define f of, all right, I need to flip my computer around. All right, f of x equals negative 2 on 9 x plus a x minus 5a. All right, so we want f of 2a. All right, so it's going to be 2a squared. So the max, the height, the height I should say, is equal to 2a squared, and the width is 6a. All right, so find the values of A for which the maximum height of the tunnel is less than. So 2a squared is less than twice the width. So 2 times 6a, so 12a. So we can probably just solve that in our calculator. So solve. We could do it by hand too, but yeah, I'm using the calculator. Come on. All right, so A has to be between 0 and 6. Yeah, we can use a calculator. Let's use a calculator more. All right, the diagram below shows the parabolic cross-section of the rail tunnel at a particular section. All right. The rectangular cross-section of the platform has a width of 4 meters and a height of 2 meters. The vertical platform wall lies on the y-axis. The cross-section of a surface area that lies behind the vertical platform is also shown. At this particular station, the cross-section of the rail tunnel is modelled by the function. All right, the cross-section of the rail tunnel. Okay. So we've got values of A this time. Find the vertical distance in meters from the platform to the top of the vertical platform wall. So I think it's actually highlighted, well, it hasn't highlighted it, but I'm going to highlight it. What's this distance here? All right, so we just want we know that's 2, so we just want the y-intercept of g of x. Now, I know on my calculator we defined it with a, so let's just drag that, drag it down, and let's just put in 2.5, and then change this to 12.5. All right, and if we want the y-intercept, remember x is equal to 0, so we just put that in. And the difference, so that's this point here. All right, so we're just going to take away 2 from that. All right, and 89 over 18, so probably don't want to leave it like that. Let's just see if it's a terminating decimal. What does it want? Okay, I'm going to leave it as, whoops, what am I doing? Wrong button. Yeah, sorry guys, 89 over 18. Doesn't say to round, so 89 over 18 meters. Right, so at this point, not really any tricky questions. So what have we got? 1, 2, 3, 4, 5, 6 marks that aren't overly difficult. All right, let's move on. All right, during construction of this station, a spotlight is installed on the roof of the tunnel at the point P, so this point here, where x is greater than or equal to 0. This spotlight must be able to project a straight beam of light from P to the point Q. All right, so it's down here, as indicated in the diagram below. Find the maximum length of the beam of light that the spotlight must be able to project. Give your answer in meters correct to 1 decimal place. All right, so we want the maximum length. So clearly that the maximum distance, I'm just thinking of different ways of doing it. We could use the distance formula and then find the derivative and let it equal 0, I'm thinking. The maximum distance will also be perpendicular to the tangent of this graph. So I'm wondering whether to do it that way. Let me just think. All right, I think I'm going to use a distance formula because that's what they use in their solution. So let's be consistent with that. All right, so the distance between 2 points. So we just basically use Pythagoras' theorem because if you think about it, oops, can you go down? Thank you. There's a right angle triangle. So it's just going to be the square root. And if we have 2 points, so we're going to have P is at our x1, y1, and then this could be x2, oops, should be minus y2. All right, so let's do x2 minus x1 plus y2 minus y1. Oh, and we're going to square them. All right, the distance formula should be in your bound book. All right, so I did have to delete just a huge part because I didn't substitute incorrectly. So the labeling is very important, and I did it, but I didn't substitute incorrectly. So x2 is 12.5 minus x1, which is x. Right, I did get my coordinates around the wrong way. y2 is 0 and y1 is g of x, and you don't have to write the whole thing out. We can just leave it as g of x. Now, you can do it on the calculator. Remember, I'm going to clear all that because that was all wrong. That's our distance formula. So let's put it into the calculator. Actually, I'm going to flip my computer. I'm sorry, I also sneezed a lot in the video that I deleted, so that was probably a good thing. And I might have to stop here also because, sorry, after this question, just because I've got a cold and I'm sniffling and sneezing and it's just not good. All right, I wouldn't go and copy that down, all right, just because I know it's worth 3 marks. I kind of think a lot of this is done on the calculator, so we can't really put too much on the, because it's just a waste. All right, we could probably write that distance. I think what we've got written there is enough for the distance formula instead of copying all this down. Now, we do want, once we've got the distance from the distance formula, because we want the maximum length, we're going to have to find the derivative of that. So finding the derivative and letting it equal 0. So that's probably a key thing to also put down, because you know how to find the maximum length. But on my calculator, I can just go straight and do the derivative. So we can do A and S for answer, or you can drag it down. There it is. And then we can let it equal 0. We could probably do that in just one step as well. So we're going to let that answer equal 0 and we're going to solve for X. And of course we get no solution. What did I do wrong? All right. Oh, didn't square this. My bad. All right, let's just go back and square that. That should work now. All right, now it just automatically changed everything for me, which you would have noticed. I just want to make sure that I haven't, yeah, I'm pretty sure that's all good. So let's just have a look at the decimal answer. Now, X, I think, says somewhere it has to be greater than 0. Somewhere. Anyway, let's just know that it is. So we've got X equals this 3.23 blah, 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 blah. So I'm going to write that down. I could also leave the exact value, but I'm just going to write X. So 234. X is approximately 3.234. But we want the maximum length. Oh, sorry, my nose is running. Of the beam. So we've got this distance formula here. So we just need to substitute that back into our distance formula. All right, let's get the calculator back up. So we've got that up here. So we can just highlight that, copy it, bring it down, paste it. And then at this point, we can just say, given that, and then highlight this to as many decimal places as you can and put it in. And oh my God, because I'm in standard mode, it's giving me the exact answer. All right, and we get 15 and to 1 decimal place. Okay, so 15.0. All right, guys. And that's in meters. So it gives us the unit of measure in the question. You don't have to write it again. So just 15 meters is fine. Just quickly looking at the solutions. So you can see there they don't have much either. So pretty much the same as what I did. Just with their distance formula, I think they had the coordinates around the other way. It doesn't actually matter because when you square them, a negative number becomes positive anyway. So no biggie there. Yeah, so you can see 3 marks. I don't know. You need to show some working out along the way. But if you're writing the whole derivative, yeah, it's just going to take a lot of time. So just make sure you've got, you know, along the way you're saying what you're doing, even though you're keeping that whole function in your calculator. All right, how much more have we got? Oh, one more question. All right, I'm going to stop after this question just because the nose is running. Sorry, that was a different question. Where's the one I'm doing? This one here. All right. Part E, a water sprinkler is to be attached to the roof of the tunnel at this station at point S. All right, so here, let the cross-sectional area of the tunnel to the left of the line X equals M. Let the cross-section of the tunnel X equals M, excluding the cross-sectional area platform be area A. All right, so it's drawn it for us, which is good. Let the cross-sectional area of the tunnel to the right be B. Find the value of M if the area of A, I knew I was going to ask something like that, A is equal to area B. Give your answer correct to 2 decimal places. All right, so I'm thinking of area, so definite integral. A is going from 0 to M, and you're going to subtract 8 because that rectangle there is 2 minus 8. And then we've got the area of B, which is going from m to 12.5. So let's set up those definite integrals. All right, so we're going from 0 to m. Oh, and we don't need to write the whole function again. So it was g of x, wasn't it? So just make sure you use the correct, yeah, so g of x, don't use f of x. All right, of g of x minus 8. Actually, don't need to, sorry, where's my thing? I'm working in the dark, you guys, because I started in daylight and now it's 8 o'clock, so can't find them. There we go. Let's do dx, and then we're minus 8 because we've already done the area, so we don't need to do the definite integral. Is equal to m to 12.5 g of x dx. And we're not subtracting anything. All right, so they want it to be equal. All right, so let's do that on the calculator. All right, so it's going to be a solve. And there's my definite integral. All right, so we're going from 0 to m. And remember, I defined it as f of x. So that's why I've got f of x on there. Dx minus 8 is equal to, and then we're going from m to 12.5 f of x dx, and we're solving for m, so comma m. All right, to find the value of m, so we've got a negative. We can't have a negative because we can see it's between 0 and 12.5. So let's just go through. We can see there's a third solution, which is 17. So we're just taking this middle value, if I can see it, 5.69. So m is equal to 5.69. All right, I'm wondering whether I've done enough working out. Let's have a look at the solution before we end this video. All right, so that's 1 mark. 1 mark left side, 1 mark right side. Okay, so just 1 mark for each definite integral. All right, well, that's not super hard. So I kind of feel like you wouldn't even need to have done anything else to answer that question, and that's 3 marks. That would not be worth 3 marks, I don't think, on a VCAR exam. Probably 2. Probably not 1, but definitely 2, and I wouldn't say 3. All right, but that question there is a standalone question. You didn't have to do any of the previous stuff to answer it, and it is quite an easy question. What was hard with this one? I don't even think any of them. Well, it is question 2 as well. So that one for me just didn't have the coordinates around the right way. So just make sure you do that. Again, I don't think this one would be worth 3 marks or the next one. But again, some quite obtainable marks there. I'm going to leave it there. I know I did say I was going to do some more extended response, but it is very hard talking and your nose is dripping and I'm sneezing and everything. So hopefully I feel better and we'll do the others later. All right, bye.